Hello everyone. Welcome to yet another exciting Ask Me session. This will be a special session because it will be an Ask Me session slash hands-on coding. So as usual, it normally lasts for an hour, but today I'll be adding like extra 10 minutes. So welcome everybody. I guess we're happy about this stage B, and everyone is active on their respective groups. That's the premier project group. So today's session will be special, like I said. We'll be doing hands-on coding and also Ask Me session. That will be towards at the end of this session. So I'll just be giving like extra 2 minutes for every other persons to join. So we'll begin. Okay, before I start, we just want to make this thing clear that everyone has been shared to their respective Premier Project group. There are 20 different groups. So if you open your Slack, you should see your groups. It's rightly arranged, like I said previously. There are data storytellers, data engineers, data scientists, and DevOps in each group. And you need to be like active in your group. For now, I guess you've already received the mail for selecting your project leads, query analysts, assistant project leads. So, and even you being a member, you have to contribute because at the end of the day, it will be vital for your certificates because it is part of the deliverables. It's also graded. So if you're an inactive member towards the end of the premier project, it will be detrimental to you. So just try and be active in your group. Even if you're in a group of 33, be active. If you are doing some part of the code or you're organizing or whatever you're doing, make sure you're active because a list will also be dropped for active members and inactive members. So if peradventure you are inactive in your group, it will affect your overall grade. So before I continue, because we have a lot of things to do, try to pitch everything under an hour, 10 minutes or an hour, 15 minutes. So do I have any question? I'll just attend to a question before I continue. Any question, just raise an hand and I'll ask you to unmute. If there is none, we'll just get on with what we have to do today. Okay. So I guess there's none for now. All right. The hands-on coding session we'll be having today will be about what the data scientists and data engineers are currently doing in stage B, which is machine learning regression. So we're going to be doing analysis of a regression and building a model from scratch, predicting. The data set we're working with would be a car data set from a Nigerian auto company. So in machine learning, supervised machine learning, there's classification, there's regression. Classification is when you're trying to, for example, if a patient has heart disease or not, if a customer will subscribe to a particular campaign or not, if it's just like yes or no. And while regression, you are trying to predict numbers, basically numbers, predicting the price of cars, price of houses, and so on and so forth. So what we're working with today will be a particular data set. We're trying to we got a data set from a Nigerian auto company. So we're trying to predict the price, that's the amount by which the company will sell a car from the available data. So I'm going to be sharing my screen, so just get into it immediately since there's no question currently. Please, I'm sharing my screen, and if you can see it, just let me know. Okay, can everybody see my screen?
Yes.
Okay, lovely.
Yes, I can.
Okay, like I said, within machine learning regression, fresh auto car price prediction. Okay, without wasting time, like we all know, we have the pandas, the numpy, seaborn for visualization, matplotlib, and all that. So let me just dive into it. Please, if you have any questions, just drop it on the chat. When I'm done, just attend to it. Okay, lovely. Let's begin. So I'm starting by importing the necessary libraries, pandas. Okay. I hope you can hear me clearly. So I know I'm not just talking about myself.
Yes, we can.
Okay,
Loud and
lovely.
clear.
Lovely. Matplotlib. Plots. Then there's something else I want to do for my visualizations to be clear, which is matplotlib inline. Then run. I'm working with my Jupyter notebook, so this is not on Colab, so it's on my system. So, all right. Then next we'll be reading the data set. The data set we're working with, like I said, is gotten from a Nigerian company. Like, name is Fresh Autos. So let's read the data set. It's already in the same directory as this my notebook. Sorry, we don't underscore CSV. If you have questions, just drop it in the chat when we're done. As I'm going along, I'll try as much as possible to answer. All right. View. Our data set is not a large data set, just 7,205 rows with 9 columns. So of the vehicle, the model, the year, the color, the amount. That's the amount is what we're gonna be predicting. You can see my cursor, this amount. Then the type, which is Nigerian use, foreign use, or whatever. Then the distance it can run in kilometers. So if you notice in this data set, this year column is supposed to be a date time, but it's like it's a normal integer separated with comma. So first thing I'm going to do is to process it to replace this comma by space. So it will just be showing 2011, 2012, 2010, and so on. So to do that, I'm going to run this particular code. Since it's a year column, I'm going to call the year column. So say my data frame df, as I'm presenting this data set, like the variable called df, just like the data frame. So this is the code I'm going to run to remove that comma to a space. There's a helper function in Python called replace. It will replace whatever thing pass something. I'm going to replace the comma with an empty space just like this. Then run. Oh, having error. Yeah, okay, yes. I need to make sure I name it correctly. Capital letter. So if you notice, as you're having an error, read the error message. That's how you decode or debug whatever you're having. So now I made an error before. The name wasn't exactly what was on the data set. So I had to correct that. So let me just view it again to see if what I did actually worked. S3. If you notice, it worked. So they were separated with comma. Now just the year 2011, 2012, 2010. So I just, is my screen wide enough? I hope everybody can see it clearly.
Yes, we can. But can we get the data set? Maybe you can just follow along or something. Maybe a link to the data set later.
Oh, yeah, that's what I should have done before now. Okay, but since we've already started, I'll share it later on. This video is already on YouTube. You can go to our YouTube channel, you'll see it will be there. So sorry about that, not sharing the data set before now. All right, so moving on. Okay, after that, just want to view the data set, that's the info, to know the data type, if it's integer, float, or object, or category, or what's not. So I'm just going to run df.info. So with this, we saw the data type of each columns. These are objects stating that this location object, which is Abuja, Ibadan, Lagos, is obviously objects. Then the one that's float here is this amount, which is a number, integer. And this distance, for some reason, is still reading in objects. But we're going to process that. Okay. Next up, we're going to check if there are missing values in our data set. So I'm going to run this code, df.isNow. This is a code to check if there's a missing. That's, if you remember our stage A, we should now have to check for missing values. So I'm going to run this. And if you notice in our data set, we have columns that have missing value, the year, the amount, the type, and this distance has a lot of missing values. So there are different ways of filling missing values, depending on the size that's missing. So these are data sets. Our data sets, the total was about 7 of missing data. So, but there are ways, like this year column and the amount column, the missing data are small. I can just drop it, but I won't be doing that.
Can I ask a question? Can I say something? Why? Yeah, this. For all those columns that you're running the code, can you put hashtag whatever it is that you're running on it? So that for someone like me, I'm walking on the road now and I'm just using my phone to follow along. If I want to practice it for each column that you're running the code, what does it do? Maybe hashtag remove missing columns, hashtag whatever, so that's, you know.
Okay, cool. I'll do that. Okay. So now, like I said, we have this missing data. There are different ways of filling missing data. We can fill it with the mean, median, or mode. That is if the data is an categorical data. So I'm going to show you how we can handle this missing data using a particular code. Just follow along. So let me just explain this, handling the missing data. All right, so the first missing value that we had was the year column. So I'm going to feed that. I'm calling the year. It's just like object-oriented programming. So that's the way I'm going to call it, the year column. Dot fill now. There's a particular code using filling missing data called fill now. That's fill NA. So then I'm going to call it to my data frame. which is the F, the year, then I'm filling it with the median of that particular column. I don't know if you understand. I'll explain further. If you don't understand, you can always drop questions on chat. Then I'm gonna set it in place true, meaning that whenever I'm calling it, the values have already replaced. So in place true, this is a particular code I can run to make it permanent. Then after that, I'm gonna be filling the other column, this amount column. I'm gonna be filling it. Let me just copy this to avoid. Please, you can tell me if I'm running too fast. Does anybody have any issues so far from here? I haven't done anything. I'm just doing processing of the data. So this, I'm still going to fill it with the median. The amount. Median values. That's the median values of that particular column. Okay. Then in place true. Mind you, this is going to be beneficial to the data science and data engineering track. For data storytelling, this might not be for you for now. So probably in subsequent times, provide something like this for you guys. So then the next column that was missing was the type column. So I'm going to feed this differently. I can't fill it using main or median or mode because it is not a number. If you notice, this type column is an object. So if I try to fill it using median mode, it should throw an error. So there's another way I can fill it. I'm just going to show you now. All right.
Sorry, I think
there's
if you run this, I think it will not work because the year column is still a string, it's still object. You've not converted it to integer yet or float.
Okay, just don't worry. You see what will happen after that. If it will throw an error or not. Just watch.
Excuse me, can you use me instead of media?
Okay, yes, let me explain that. The difference between mean and median, when you are filling a missing value, I prefer using median because median is more, how would I put it, exhaustive. Like you won't run to any issues using median. With the mean, personally, I don't like filling missing data with mean. Median is more, I don't know how to put it, exhaustive.
Median is more,
it will be more better.
Outlier, it's more robust to outliers.
Robust, yeah, than the mean. So it's best you fill it with the median.
Beautiful.
So moving on. Even if it throws an error, there's a way we will go about it. It's part of it. So I'm using something called in Python, there's a way you fill missing data using forward fill or backward fill. For example, in a particular data set, probably the first in a column you have 2000, then the next column you have none, that's missing value. So I'm going to use forward fill. I'm filling the next column that has a missing value with the previous column. So for example, if the column value was 2000, the next one was missing, it will just fill it as 2000 still. So that's what I'm going to be using. I'm going to be using forward fill. It's a method in Python. So just try and follow along. So in place true. Right, then the next one, the distance. First of all, if you notice in our column, this distance column, I'm going to try to run fast. I have a lot of things to do. The distance column, we have this, they are separated by commas. So still, we still have to replace it because if I run it with whatever I want to do, it will throw error. So I'm going to replace this comma we're having to an empty string. So it will just be the same like we did for this year. So I forgot to do it the first time. So I'm going to just run the code here. df distance. Try to follow along. String, since it's a string, dot replacing the comma with an empty place. And after that, I can fill missing values. Now, this session will last more than an hour. That's what I'm saying. I have lots of things to do. So I'll be adding an extra 15 or 20 minutes. Hope we don't mind. In place true. Okay, so we're good to go. Let's run. You notice we don't have any errors. Person that asked that question, can you see we don't have any errors? We don't have any errors.
Hello, sir. Please, the method as in used, the method equal to ffill that you used in df type, as in what actually does it do?
Okay, I explained it. I'm not sure you heard me. I said this ffill, I can't fill this distance, sorry, this type because it's an object, not a number or integer. So this forward fill, what it does is that, let me go back to my data set. For example, this place we have 200,000, and this next place is a missing data. What it does is that it will fill this missing. Can you see my cursor? Can you see my cursor?
Yes, I can see it.
Okay. It will fill this missing data with this 200,000. So whatever comes before the missing data, it will just fill it. That's what we call forward fill. There's another one called backward fill, just like this. If it was backward fill, it will fill this missing data with this 85,000. So do you understand?
Yeah, I understand now, but
so that's just what the forward fill does.
Won't it affect as in your final as an output? Like the
Not
place
really.
is empty and you hello, can you hear me?
I can hear you. I said not really. I can hear you.
I said as in won't it like will I say affect your final output after everything because the place is like empty. I suppose maybe you should use something like 0 because it's an empty space kind of to fill it.
Zero will be more detrimental to your data because you are filling it with the actual values already in your data set.
Okay.
Sorry, sir. I have a question.
Do you understand? So it won't throw an error. So if you notice now, we don't have any missing data. Whatever questions I have to reach through, I'll explain everything when I'm done. So, okay, moving on. If you notice our data sets, we have to convert the ones that are objects to numbers as integers. So what I noticed, what I'm going to convert to be the distance and the year column. I'm going to convert them. And there's a method to do that in Python. So just try and follow along. So I'm calling the data, which is the distance. I have a lot of things to do. Yes, we're going to use 2 hours on this one. As type. So what I'm doing here is that converting the data format, that's the type, to a float as type float. That's for this distance column. Then my year column, I'm going to convert it as type integer. Float and int, they are numbers, so they are more like the same. You know, our data types, floats are numbers that are decimals, so I don't have to explain that by now. So for this, I'm going to change it to as type integer and I run. So then to confirm again, if you notice, the year column changed and the distance changed to a float. So this is what in machine learning does, data science, preprocessing. So I'm just preprocessing the data. Yeah. Okay, moving on. When you're building a machine learning model, I'm getting close to building the model now. In your data sets, you can, there's what we call feature selection to know which would be important to your model when you want to build the model. But there are sometimes you can just know without running that. So for me, I notice if you can see my cursor, the vehicle and the location, from what I can deduce, they might not be important to me running my building my model. So these are just arbitrary numbers. I can just decide to drop this column and drop this other column. So they're not useful when I want to create my model. As I'm going forward, you understand what I'm trying to say. So there's a code in dropping that. This is in stage A, df.drop. I'm dropping the 2 columns. So it's just what I decided to do. I decided that those 2 columns won't help me in building my model. There are some questions in the chat. When I'm done, I'll reply. Don't worry, we'll reply those questions. So vehicle ID and the location. Location. Then as is 1, meaning my column, the column as is. That's why I'm dropping the columns. If it was as 0, you're dropping the rows. So I hope you understand that the difference between as x1 and as 0. Then in place true. I have an error. So what's the error? Vehicle ID not found. Okay, the spelling of my vehicle ID column. Capital letter V. All right, so this is just an example. Whatever error you're having, just go to the last place and read the error message. Then from there, you know how to debug that error. Simple as that. So if you notice, I've dropped the 2 columns that are no longer in my data sets.
Hello.
Hello, I can't hear anything.
Same here, I was thinking it was my network. Maybe you would log in. Yeah. But do we think
we'll just have to wait.
Do we think you should drop the location column too? I feel location column is still relevant in a way.
It's true because I think prices are different location. Are different. Prices are different locations. They're different, kind of.
Hmm.
Can you hear me now?
Yes, we can hear you.
Yes, you can now.
Yes,
Yeah, sorry about that. Okay. Like I said, I had somebody asking a question if it's necessary for me to drop the location, if it's still needed. Was that your question?
Yes, I was saying that the location might still matter in our modeling. Okay. Maybe with respect to prices and all.
Okay. Don't worry. When I'm moving forward, you see why I decided to drop it, if it will be useful or not, or if it will affect it in a long way or not. So as we move in, just see what I'm trying to do. Time has already gone far. So, okay, as I was saying, when you're building a machine learning model, like computers, they work with zeros and ones. I don't know, you can hear me clearly now, right?
Yes, you can.
Okay, lovely. You have to convert whatever object columns like this one saying Hyundai, Lexus, GLE, red to numbers. So there's a helper function I'm going to use, just try and follow along on how to convert it. And we're using what we call label encoder. There's label encoder, there's one hot encoding. This is just converting categorical data to numerical data. So that's label encoding. The difference between label encoding and one hot encoding is that one hot encoding will represent them in zeros and ones. But label encoding, for example, like we have in this model, we have Sonata, ROX, GLE. Label encoding will convert this, probably Sonata will change to 1, RX will turn to 2, GLE will turn to 3, Highlander will turn to 4. But one hot encoding will just create a totally different column for it. So I'm going to use label encoding. But first, I'm going to run a code which will differentiate my categorical columns and my numerical columns. So just try and follow along. In case you can't hear me, you can just call my attention to it so I'll know. So I'm going to run a helper function to check for my categorical columns. So I'm going to say include. From what we did, that df.info, we already knew which was object, which was category. So I'm going to say include object then category dot columns. Whatever I don't understand, I'll explain later. That's an issue. Then my numerical columns would be I'm going to run a function for this, saying column for columns in my data set dot the columns. Yeah. If column not in this my categorical column I just defined before, not in categorical column I defined previously, right? Print categorical column. So the categorical columns we have are the maker, the model, the color, and the type columns. So these are the ones that are not numbers. Then for our numerical columns, Just to print. Is there anybody that's lost so far? Yes,
me.
This session is recorded. It's live on our YouTube. You see it after now.
Okay.
Okay. Yes, there's a question. Say any particular reason for choosing forward fill instead of mode? Yes, because if I use mode for the year column, it's an object to throw an error. That's why I decided to use forward fill. That's that. Moving on. Okay. For type, not year, sorry. I did forward fill for type, not the year. I did median for the year column. It was the type I used forward fill because it's an object. So now, to encode, the reason why I did this is just to encode my data set. That's converting the objects to numbers. That's what I just did. So, right. Label encoding. Don't worry, after this, you see this video on our YouTube. After what I'm doing, I will try to explain it. If you still don't understand, after my explanation, you get the video. It's on our YouTube channel. So what I'm going to use a label encoder is it's a library in scikit-learn. So I'm going to import it from scikit-learn. Say sklearn dot preprocessing import label encoder.
Your learn is not complete. Your sklearn is not
complete. Yeah, thank you. Sorry about that. There's always typo whenever you're running codes. Thank you about that. No need for one to code. Then I'm going to give it a variable called LE. Then I'll call the label encoder. Then, so I'm going to say for the categorical columns, I'll transform them using label encoder, using this particular code. For items in categorical columns, my data frame for items. So I'm just calling these items that I'm trying to convert to be equal to my label encoder I just presented before as LE dot scikit-learn libraries, the label encoder. You know how to work around it. There are documentations for that. And I hope you can hear me clearly. So if you can't hear me, you can just signify so I know I'm not just talking. Can you hear me clearly?
Yes.
Okay. Yeah, we can.
Okay. So this line of code will convert the objects, those type, the color, and the rest to numbers. If I run it now, you see it running, no errors, lovely. And let's confirm again. So if you notice, our columns have been represented to numbers. So you know that this maker column has different types of maker, the Sonata, the Hyundai, the what have you, then the model. If it was one hot encoding using what we call get dummies by pandas, these columns will be more, it will represent them individually. So that's the advantage of using label encoder. Label encoder is more robust, kind of. I prefer using label encoder. So if you notice, everything changed to numbers. If it wasn't in numbers, if you run into a machine learning algorithm, to throw error. So I hope you understand that. So moving on, from this stage B, you were working with linear regression, but what I'm going to work with, I'll be using several other regression algorithms. If you check the scikit-learn library, there are lots of regression algorithms. There's random forest, cat boost, gradient boost, S boost, SG boost, decision tree, k-nearest neighbor, ridge, and all that, and linear regression. So to confirm which particular algorithm will be suitable for this, my data set, I'm going to be using 5 of those. So I'm going to be using random forest, cat boost, gradient boost, linear regression, and the decision tree regressor algorithm. So I'm going to be importing all of them from scikit-learn and the respective libraries. Hope we're following along. Any issues so far? Any issues so far?
No, good.
Not really on my side.
Okay. Okay, no problem. So random forest regressor. Then from cat boost,
Sorry, am I the only one? Can we still hear me?
Me too, I
yeah,
can't
it
hear.
was from my end. It's from my end. Can you hear me now? It was from my
Yeah.
end. I had to
All right.
reply something. Sorry about that. So moving on. Can you hear me clearly, I guess? What cat boost regressor? I have a lot of things to do. So this will be more than an hour. So then I'll be using gradient boosting regressor. So from sklearn, if you go to the documentation, you see how to call these algorithms. It's in the documentation in sklearn. So I'm not doing rocket science here. So gradient boosting. Then linear regression. Let me just use this for random sklearn. Hope you can hear me clearly. I hope I'm not talking to myself. Anybody that's lost, don't worry. After the whole thing, you'll be found. We'll look for you for where you are lost. We'll find you. Even if you're not following along, you're not getting it now. You will get the recording is on our YouTube. You see there, our YouTube channel. So, okay, I'm working with this 4 algorithm to create my model. Then also, I'm going to import what we call the train test splits, meaning I'll be dividing my data set into training and testing. So to do that, there's a library in scikit-learn for that. So I'm going to call that. I'm calling that from typo. Out of it. Dot model selection. called train test splits. It's called train test splits. It's a library scikit-learn. It's there in the documentation. I'm not doing rocket science. You see it there. I didn't create all this code. It was already there. Then I'm going to be also importing my metrics. There are metrics for regression. If you started the course, you should know by now there's mean squared error, mean absolute error, the R squared score. So I'll be using 3 different metrics after I've created and built my model to see if my particular model is good. So learn also from scikit-learn dot metrics. To score. I won't be using this though, but I'll just import it. Mean absolute error. Then the mean squared error. I will explain what these metrics does. That's their functions as I'm building model. So just sit tight and relax. Okay, then run. I don't have any typos. Lovely. Hope you can see hear me clearly. So I know I'm not talking to myself.
Yes, sir.
Yes, we
Wonderful.
can.
Are we too?
Whatever question I have here, I'll explain afterwards. So to save time, I'll just explain. Let me just move on. So I'm going to be splitting the data into X and Y. Okay, why I'll be doing this is because, yeah, somebody was asking on the Slack channel. The column that's our target column, that's where, remember from the problem onset, that's this problem statement. We're trying to predict the amount for these cars, the amount this particular company will sell these cars using this available data. So the amount column will be our target column, which will be the Y variable, that's the independent variable. Then the X data will be every other data except the amount column. So I hope you understand what I just said. Let me run through the sheets. So I'm going to be dropping the amount column from back to make sure. Okay. Amount, Control C. Drop, then as is one. Good to go. Lovely. Then the Y, no, nothing else. Yeah, the drop. Okay, yeah, this is supposed to be inside. One, okay. Then my Y column will be only, my Y column will be only, that's my Y variable will be only the amount column, that's the independent variable, which is the target variable. So then run, no errors, lovely. Okay, moving on. I'm going to be splitting the data into train and test sets using what we already imported before. So if you're still having questions at the end, I will explain everything. So let me just write it out so you understand. Splitting the time. Wow, this is not for a long time. Okay, splitting the data into train and test sets. So doing this, there's a way that's already been set out in sklearn. So splitting into train and test sets, we call it S train, S test, Y train, and the Y test. That's your S and Y variable. So I'm going to call it. It's in the documentation. I didn't formulate this myself. So if you go back to the documentation on train test, please, on scikit-learn, you see all these things I'm doing. So it's not okay. Y train, Y test. So I'll be calling what I hear me clearly. Just so network issues just S Y. Then the test size. Okay, this test size means how I'm going to be splitting my data sets. So I'm going to be using 20% test size at 0.2. All right, okay, good. So meaning my test data set will be 20%, then my training data set, what I'm going to be training the model with, will be 80%. So this is how it's done in supervised machine learning. Then I'm going to call another variable called random state. This random state, what it does is that whenever you're running your model multiple times, you always arrive at the same particular range. That's a particular range of numbers. So instead of as you run it now, you didn't include this random state. If you run it again, you get something else. So random states, I chose random state 42. You can use random state 130, but the standard one I like using or that is recommended is random state 42. Okay, run. No errors. Then moving on. Okay, since I said I'll be using four, if you remember the previous time I said we'll be using four different models, that's algorithm, random forest, CAD boost, gradient boost, and linear regression. So to do this in coding generally, you can do some helper functions to help you whenever you're running your model, instead of doing what we call redundant coding, instead of running your code back and forth, you can just create a helper function. So I'm going to be creating a helper function now to include my models. So let me just write it out as I'm explaining. So putting models in a dictionary. So I'm going to call models, that since I'm using four models, when I'm done with this code, you understand what I'm trying to say. In a dictionary, to represent dictionary is curly braces, curly brackets. So let me call the first one. First model was random forest. Okay, let me just say random. Present it as random forest. Then you know how you create dictionaries in Python, right? I don't think I should explain this. So I'm just representing it in a dictionary. You see as I'm done. You understand what I'm trying to talk about? To help me, instead of rerunning the code every time, I can just call this function. That's the benefit of creating functions in Python. Random forest regressor. Call it with this bracket. Then the next one I said will be cat boost. So let me just represent it as cat boost. How about following along? Even if you're not following, I'll say explain later on. You can ask your questions. So for those that are following along, can just signify if I'm not boring you. It's jargons.
No, interesting. I'll continue. Thank you.
Okay,
yeah, please continue.
So cat boost regressor, that was the next. Calling it. Always whenever you're calling it, as you've already imported it, then if you are calling the function, always includes this brackets or whatever they call it. So if not, you run to errors. The next one I said I'll use gradient boost. Let me just represent it as gradient boost. I'm putting it in a dictionary, so gradient regressor. Did that correctly? Gradient boosting regressor. Okay, lovely. All right, then the last one was our linear regressor. I'm just doing that.
Hello?
Hello? Can you guys hear me? Can't hear him.
Yeah, I can hear you, but I
Yeah,
can't
you
hear
Network problem.
Yeah, we can hear you.
He's having network problem.
In our range. Okay.
Hello, Mr. Christian.
Just had a slight network issues.
I believe you're the one that is always sending us that message about strong network connection.
Yes.
Yes, so you are the one that is sending us that message, and your own network is so strong.
Nice stroking, nice stroking. Okay, moving on. I like that. Can you see it clearly?
Yes, we can.
Yes.
Okay. Okay, now I'm going to write another function, right? That will help me call these particular models. Let me just write it so you see. People are just joining. Wow, interesting. Okay, def, I'm going to call it fit and score. So instead of wasting time, string.
Looks like it's very serious. Can anybody hear me?
Yeah, we can hear you. I think he's having network glitches.
Okay, it's fine. think he's disconnected.
We have been left alone, guys.
Wow. Interesting.
You've been offline.
Yes, I don't know what's going on today, but sorry about that. Can you hear me and see me clearly now?
Yeah.
Yes, clear.
I don't know what's happening. It's like I'm in a terrible network bandwidth today. So I'm in another place different from where I was, so probably that's why. So okay, like I said, I want to be creating my random seed.
Maybe you should change your location. Maybe it would help a little.
Or even change the network.
So I've avoid this network issue. I just had to move to a different location. Sorry about that. You can hear me clearly now. Let me just run through very fast.
Yes, we can hear now.
I moved to a different location, so to avoid, I was having updates of broadband issues, so I just tried to move very fast. Okay. Model scores equals to my dictionary, curly braces. Okay. Then looping through the models. This is just my personal function. It's called helper function. You see why I'm doing this to save time for me calling the models individually. So I'm going to say for name model.
Sorry, please, np.random.seed42. What is that?
Is the same thing as this random state.
Okay.
Yeah. It's another way of calling random states using is a numpy function. You can do that in numpy. Okay. Models.items still have a long way to go. I hope you can see my screen clearly. Yeah?
Yeah.
Okay. So for the name and the model, that's for the name and the models in this my dictionary, I'm going to be fitting each model at that's simultaneously. So this is an helper function. So instead of me running them individually, so that's a waste of time. Then next will be evaluating the model. I'm going to call it the scores. Don't have any errors. Okay, scores, then name. If you don't understand the function I'm doing, this is my personal function, I'll explain. Let's test. Test. And return model scores. Okay, let's run this and see if we have any issues. Lovely, no errors. So moving on, let me call my function I just created using this timer function to see how long it will load. So scores, remember I created a function called model scores. Scores will be equals to this fit and score I just created. So I'm just calling that function, fit and score. So normally these are how they created functions, that's pre-installed functions in Python. You can also create your own functions and save. So this is an example of that. Models equals to the models I called. The S string in my function will be sorry, this is taking too long, but it's what it will be my S string of my data sets. Then the Y train for the S test of my function is equals to the S test of my data set. Okay, then next, there's a Y train in my function. Y train will be equals to Y train. Then Y test will be equals to Y test. So you see why I did this. Okay, then call the scores. It's going to take a little while, let's say a minute or 30 seconds to run. While this is going, you notice, yeah, my model is already processing. So it's done. So I'll see the best model. So if you notice, the best model in each of the model I used was cat boost. It has 0.89. Hope you can hear me clearly.
Yes, I can.
Yeah.
Yes,
Okay.
I can.
So if you notice, this function I just created, under 30 seconds, I ran 4 different algorithms. In fact, it's even 7 seconds. You can see my cursor, what time, 7 seconds. So that was why I created this helper function. Instead of me running random forest, go again, run cat boost, run gradients. So with this, I used the 4 different algorithms and I got my best was cat boost, which was 0.89. And mind you, in regression algorithm, the default scoring metric is the arrow squared. So what you are seeing here is the arrow squared. If it was classification, the default scoring metric is accuracy. Right. So
this values here, they're not too poor. 0.8.
0.8, yes, of course, you can also have an option of doing what we call hyperparameter tuning.
Okay.
Okay, let me explain. I will explain each of the metrics for you. The arrows, the arrow squared, the mean absolute error, and the mean squared error. You see what I'm talking about as we move on. So for now, my best model, that's my base model now, is cat boost without using any form of tuning, hyperparameter tuning or grid search CV. So I'm going to use base model first of all, so you see if it's good or not. You understand? So now I know that my best model was this cat boost. So let me just call it again. I'll just say CBT, which is my cat boost, is equals to cat boost regressor. So now I know my best model out of the four. So let me just call it again because it's different. CBT equals to model.fit. So it just saved me time instead of run them individually. S train, Y train. Then I'm just run again to show. Okay, I have an error. What's the error? Model is not defined. Okay. Sorry. CBT that fits. So yes, that's done. That was fast. Then next is to score it. So what I'm doing, I'm just doing what my other function helps me with. So I'm going to do it again because I didn't have it saved normal. So instead of calling all the functions I created, so I'm taking just the cat boost. So it will be my cat boost model dot score S test Y test. S test Y test. Okay. And brought back what we had previously. Then now I'm going to make predictions first before I can evaluate it using metrics, the R2, mean squared error, and mean absolute error. So first of all, I'm going to make my predictions first, then analyze it using the metrics to see if it's good or not, or if it's far from whatever. So CBT dot predict is a function. Cyclic you're predicting with your S test, which is your test data. Then I'm calling it ypreds. I just named it ypreds as a variable. So these are the predictions of the amount the model got. So to know if it's working well, I'll now start using my evaluation metrics. So let me explain it now. The R2 pronounced as R squared score is also known as coefficient of determination. Coefficient of determination. Can you hear me clearly? I hope you can hear me clearly.
Yes.
Can you hear me clearly?
Yeah.
Okay.
Yes,
So
yeah.
what this R2 scoring does, which is this default score here, if you can see my cursor, it compares your model's prediction to the mean of the targets, which in our case, the target here is the amount, that's the price. And the values can range from negative infinity to 1. 1 is a good model. The negative infinity is very poor. So if you notice, the score we had here was 0.89, more or less 0.9, which is also good. Yeah. Then there's another metric you can use, which is the mean absolute error. The mean is the average of the absolute differences between predictions and actual values. I will show you how that is done. I will just do a visualization for you to see it. The mean absolute error matrix is the average of the absolute differences between your predictions and your actual values. If it will tell you an idea of how wrong your predictions were. The Y mean squared error or root mean squared error is the average squared differences between predictions and the average and the actual values. So instead of talking, let me just run the code, you see it's what I mean. So first off, using the mean squared error, sorry, mean absolute error, which is May. Remember, I imported it from sklearn previously. So mean absolute error. mean absolute error, the way to run it, you use mean absolute error, white test, and your predictions. Your white test you created before, and the YPred, this YPred that is, that's my predictions. That's how, so that was how I had to make the predictions before I can evaluate it. So this is the default way, that's the documentation on scikit-learn how to use this particular library, that's this code, this called function, whatever you want to call it. So YPred. Okay, then let's call it mean absolute error. You notice that mean absolute error is 2.91. From the definition, I said mean absolute error is the average of the absolute differences between prediction and the actual values. So if you notice now, these average values of differences that we have, our model achieves a mean absolute error of 2.91, or yes, 2.91, which means on average, our model predictions are 2.91 units away from the actual value. So let me put it in a data frame so you understand it. I put it visually for you so you see what I'm trying to talk about. I hope we are following along. You can hear me clearly?
Yes.
Okay, lovely. So let me just create a data frame called df2, which is there's a function, the way you create data frame, there's a function for that. So that's what I'm going to use. It's called pd.dataframe. I want to create it. I'll say my data. Let me even show you what I'm trying to say. If you notice, I just did this function called pd.dataframe. If you do this, can you see my screen clearly? It will show you. Can you see this thing? My cursor. Can you see my? Okay.
Yes.
It will show you what you can impute in this particular function. You impute your data, the index, the columns, and what have you. So that's what I have to represent now. Just follow me clearly.
Sorry, how did you bring it down?
Okay, I got it that if you're on Windows, you can use, if you see my cursor close to where the bracket is after calling data frame, use Shift and Tab. If you're on Mac, it should still be the same, Shift and Tab. It will show it as Shift Tab. Voila.
Thank you.
All right. So the data will be equals to, I'll call it, I'm creating a new function, and that's a new dictionary using my curly brackets. I'll name it actual values, which was already in our data set. Actual values is the white test we had before. Remember remember when we splitted the data into X and Y? The Y was our amount column, which is the target variable, otherwise known as independent variable. So the actual values is our Y test. Then my predictions are called, let me just call it predictions. Oh, sorry. Predictions. Hope you can hear me clearly, please. Just let me know.
Yeah. I hear you.
Okay, lovely. I hope it's not too boring. So I just created the data frame. Then let me call it so you see what I'm trying to say. All right. So if you can see my screen clearly, these are the actual values. These are the predicted values. So this way, in our data set, the actual value was 6.5 million. Predictions said 8 million, which isn't that far off. 56 said 50, 2.59 to 3. So this is just what I was saying about the mean absolute error metrics. So if you notice, our model isn't that bad per se. This is just the base model. And now it's not just, we haven't seen it further. These are the actual values, then these are the predicted values. So let me put it in a diagram for you to understand better, but that will take more of our time. So That is that for our model. There's another option you can use to further make this particular model better for hyperparameter tuning. So you can go back and research on how to do that. So our model is not that bad. 56 is the actual value, is saying 50, quite cool. 2.5 or 2.6 is saying 3.4. 25 actual value is saying 23. So our base model is actually quite good, not bad. So that is that for in building, analyzing, processing our data, and arriving at a regression model. So thank you very much. If you have a questions, you can shoot.
Question.
Okay.
Yeah, I think this is exactly similar to what I am used to by manual method, the regression method of regression. My question is, will you send, first question is, will you send us this data set? Let's work with it.
Yes,
then the second question. Okay, the second question is, I'm going by regression analysis. Which of the method of regression is most used by Python dictionary?
Which what? Sorry?
Which of the regression methods is used mostly by Python library?
Okay, I won't say which is mostly used. It depends on your data set. Like there are some data you have, linear regression will do it for you, while there are some linear regression would be good. It's just for you to know the statistics behind it. Then
okay, you wanted to show us how to choose the type of regression to carry on. Regression analysis. Yeah, you wanted to show us that before now, how to make that choice of what type of regression should be carried on the data set.
Okay, if you notice okay, let me show you. I didn't visualize it. If I visualize it, you see better. Okay, if you notice, can you see my cursor?
Yes.
Can you see my cursor here, where we have this random forest, cat boost, gradient? If you notice, the best score here was cat boost. Linear regression didn't do it, it was 0.2.
Okay.
Can you see it?
Yes, sir. Yeah.
So, okay, let me just put it in a visual. Let me run it. Let me put it in a visual so you see it better. Just run it. Let me call it compare so you understand better. Because if you see it, that's what data story comes into play. Hope you can see my screen clearly.
Yes.
Okay, so data frame scores, index the I'm just creating a function, just try and follow along. To score, because the default scoring method in regression is the
R square.
So I'm just going to show this so you see what I'm talking about. Then compare will be equals to transpose dot plot. I'm using a matplotlib library, which is the bar plot.
Yeah.
Then let's go. Oh, I have an error. What is error? Okay. Compare dot t dot plot dot bar. Okay, if you see this visual I just did, can you see it clearly?
Yes.
So if you notice, amongst the four algorithms I use, these are linear regression algorithms, so from scikit-learn. The best performing one with this particular data set.
Yeah.
If you notice, linear regression didn't do well. Anybody see the screen?
Yeah.
So with this, as I did this, I created this visual for you. So you should know that if you create your model using linear regression, you will have a terrible kind of model for this particular data set. Then there are some, that's why you need to understand the data sets you have. Once you're done with your processing, cleaning and all, yeah. That's why in data science, statistics is still very good. So with this particular data set, I just did a base model, and you can see that linear regression didn't do so well. So the best was just random forest, cat boost, and gradient boost. And mind you, in machine learning, scikit-learn models as a library, random forest is quite a good algorithm. Random forest regressor or random forest classifier. So random forest also did good 0.81, but cat boost did 0.89 R2 score. So this is how you know that linear regression won't do well in this particular data set. So do you understand?
Yeah, thank you.
Okay, any other questions so far?
Yes, sir. Okay. Sorry, can you scroll back to your helper function?
Okay.
Yes, thank you.
Okay.
In this helper function, you called numpy.random seed here.
Yeah.
And it was not assigned to any variable, and it is not used anywhere. I can't say anywhere it is used. So okay. I still don't understand how you created it, what is really doing there.
Okay, let me tell you what is doing there. Can you see my cursor clearly?
Yes, I can very well.
This is the function. This fit and score is my personal helper function.
Of course.
This random seed is already set inside this function. So it is already functional inside my function. If you notice, I said, okay, I created a random seed. Okay, if I didn't put this np.random seed here, I could also put it. Where else can I put it? Yeah. Okay. I don't think I can put it anywhere else inside this my function. So it is already functional. I can change this np.random seed to 1. You will notice my result I will have would be different. The function of random state or random seed is to give you a recurring result every time. Instead of you running your function and you get a particular result, you run again, you get different thing. Random seed makes it stable. So it is already functional under this my function. If you notice in Python functions, I created using its def. So if you are familiar with Python, it is still under my function here. So it is functional, it's working.
Okay.
Do you understand now? So I don't need to call it inside anywhere. So that's why I said for you to build more on, if anybody's a beginner or intermediate, to build more, you need to still learn how to create functions to help you in the future. Because there's what we call pipeline. There are pipelines of preprocessing your data. Instead of me processing my data in different cells, I can just write it under one function. Like this function is called fit and score. I fitted the data, I scored the data. This is my 4 different data. I can also make this into 10. So if my data algorithm here, that's my regression algorithm, I can use 10 different algorithms. Just with this simple helper function, I'll get my answer fast. So that's why I just got to know the best model, which was cat boost. So do you understand now?
Yes, sir. That's all right. Thank you.
Okay. Any other questions so far in the chat?
Sorry. When you were going through this whole session, you were kind of fast and you promised to go back. So I don't know if you can start from the top again, to give proper explanation to each of the steps that you ran through.
Okay. I'll still go through it fast though, because we've already wasted a lot of time. You can also see this recording on our YouTube, so for you to go back and understand better, but I will explain it each step. Okay. For this, normally, we're importing our HEPA libraries, pandas, NumPy for numerical analysis, Seaborn for visualization, Matplotlib for visualization. Then in this other place, we read the data.
Yeah,
here.
you didn't explain, sorry, please, the Matplotlib inline.
Inline. Okay, this Matplotlib inline is like a what we call magic function in Python. If you notice, I did a percentage sign here before I call it. It makes your plot, how do I put it? Let me put it in a simple term. It makes your plot like stay in a stable place. For example, instead of your plot to be scattered, it makes it arranged in line. What I did in line here means that it will go towards the left. So do you get me? It's just like this magic function to make your plots full and fine. So even if I didn't call that Matplotlib in line, my plot will still be good, but I like calling that so as to have a good visual.
Okay.
So then moving on, in my data set, if you notice the year column, instead of it to be a year, it's like numbers that amount 2001. So this code I did here was to replace the commas to single space. You understand that now? Yeah?
Yes, yes.
Okay, then I did this code to check my info, the info, to know the data type. That's the if there are objects, floats, categorical and numerical data. And I did dev.isNow to get the missing values in my data set. So got 21 for year and all this for each column. Then this particular code here was used in filling and replacing the missing data. Like I said, the way you know how to handle missing data, for example, this particular data set has 7,200 rows. And this year column, the missing data are just 21. I can just say drop NA. It will not affect my model or whatever I want to create because it's very, very small. But this distance, I cannot just do drop NA because 2,000 is like more than 1/4 of 7,000. So almost 1/3. So this function here, I just did to fill the missing data, which is the year. I filled it with the median, that's the year column. The amount, I fill it with the median value. You can fill it with main, mode, or median, but I decided to use median because median is more robust than the rest. It will give you a good data set. So from research, that's how I knew that median was good in that aspect. Then for the type column was an object. It wasn't a numerical column. If you notice here, the type, can you see it? It's saying Nigerian use, foreign use. So if I did filling by main or median, it will throw an error because main and median obviously are numerical. You understand?
Yes.
Okay. So I'm still explaining this for those that are just joining. You can just follow along, no need to ask again. Then for the distance, before I filled it using median, if you notice, it also has comma, separated with comma. So I just used what I did for the year to replace the comma and put just a space. So that was for that. Then I filled it with the median. Do you understand to this point? Okay. Then also I converted the data type. Yeah, using the distance column and the year column. They were previously objects. So I discovered that there's a way I could change it to.
Sorry.
Do you understand? What's the question?
Yeah, sorry. You performed the you handled the year data using the median, but still object. So how did it work?
Okay.
Or why did it work?
Yeah. Okay, why did it work? Okay, I will explain now. Let's go back to the year column. If you notice, the year column was still, this is like numbers. Do you get? But Python is really Python is reading it like it's an object. But why it worked was because the function of Python, that is fill now, only works with numbers. It's also a number, but the way it was saved, that's the way the data set was encoded. Unmute yourself, please. Then, because it was encoded as if it was an object, but it worked because it's numbers. Do you understand now?
Okay, yeah. So when you replaced it with when you replace commas with empty strings, it changed back to numbers.
Yeah, it didn't change back to number. That the type was still object. I just removed that comma. It doesn't affect the data type. But because normally, defaultly, those things you see there are numbers. But the way the data set was saved or encoded as this data engineering stuff, it's Python read it as an object of which normally it's numbers.
Yes.
Okay, so that was why it worked. So that's why you were asking that I didn't command it to work. So that was why it worked. Do you get?
All right.
Okay, now moving on, I converted the distance and year to integer and floats. I did this because, of course, it is already numbers, but Python recognized it because it was already saved in encoding the data sets from data engineering people. They made it, Python recognizes it as an object, but normally it was numbers, so I could change it to float. If it was this maker column, I could not do that, it would throw error. So the lady asking this question, please, are you following attentively? Are you getting to this point? Yeah?
Yes.
Okay, lovely. All right, then this is just a code I did in bringing out the numerical columns and the categorical columns. Numerical columns are columns that are numbers. Numerals are numbers, be it float, integer, or whatever. Then the categorical columns are object columns, like this color. No color is red, green, blue, whatever. So I just did this code here to represent the columns. It's just a particular code in Python. So then the one you should get to know is what we call label encoding. If I passed this particular data set straight into my algorithm, it will throw error because normally no computer works with zeros and ones. So if I did that, it will throw error. So I had to convert my data set into numbers. Do you understand? So using label encoding, it's a particular library in scikit-learn. You can know more about it. You can just check the documentation. You know how I did this. So I transformed the categorical columns into numbers using label encoding. So if you notice, each of them represented a particular column, that's the value to numbers, each of them. There's something else you can do called get dummies. That one is a pandas function. Get dummies, the issue with that is that it will create a lot of columns. For example, in this maker, you have a lot of different makers. It will create each column for each. For example, we have Yonde. To create a column for Yonde, to create each, so that would be too much. So that's a label encoding. I prefer using label encoding. Right. Then moving on, I use different regressor algorithms. So I'm just doing a recap of what I did. I use different regressor algorithms. So the one you're learning currently in stage B, if you're data scientists or data engineers, you're doing the same course currently, you're just talking about linear regressor. But there are so many other regression algorithms in scikit-learn. Yeah, so I just choose these four. You can go to scikit-learn library about their regression algorithms to see the rest. There's SVR, support vector, regressor, CAD boost, gradient boost, k-nearest neighbors, k-neighbors, and what have you, what's not. So this was what I used. Then I split the data into X and Y. Since, for example, since we're running a particular model, yeah, creating a model, and our target variable is this amount. Like I said from the beginning, we're trying to predict the price of these cars using the available data. So the independent variable, which is our target variable, is this amount column, that's the price. So what I did for the X column was that I removed the amount column and left every other thing else. Then the Y column was just the amount. Then I called, there's another function on sklen, which is called train test split. Yeah. I call that, this is a function I use in splitting your data set into your training and testing data sets. You train the data set a particular amount, that you train your model with the data set with a particular amount, then you test it to a particular amount. So I divided it using this test size. 20% was for the test size, meaning 80% will be for the what do you call it, for the training size. Yeah. Ahmed, I'll answer you. Wait, let me just explain this. I'll get to you. Seeing your hand. Then after that, I created a function. This is just my helper functions in running this whole model instead of me running them individually. So not so as to save time, I just created a function. This is my personal helper function here. So if you go more into Python, you know about functions, it will help you. Then after I ran that, I got the scores of each particular algorithm. You can see it here clearly, right? Then after that, I noticed that it was CatBoost that had the highest score. The default scoring for regression models or algorithms is the R squared, which is R2. So after that, I discovered that CatBoost was best. Linear regression didn't do well. Random forest, not so good. Gradient, also good. So I tried to go with CatBoost. This is a base model. There are other ways you can fine tune your model using hyperparameter tuning. But I didn't do that here. I just did a base model. Then moving on, I chose that. I did my predictions. All these are under scikit-learn. I didn't create this. It's under scikit-learn library. You understand better once you go to the documentations. This is how it's done. Then after that, there's what we call metrics, evaluation metrics. There's the mean absolute error. I explained that before, which is mean absolute error, which is the average of the absolute differences between predictions and the actual values. So I use mean absolute error. If you notice, we had a mean absolute error of 2.9, meaning our model has a mean of 2.9, which means on average, our model's predictions are 2.9 units away. For example, if the reprice was 15, probably our model predicted 17 or 18, or if it was 15, model predicted 13 or 12. Do you understand? Right. Then moving on, I just did a visualization to show the different models we created. So that's for that. So do you understand everything clearly? If you still don't understand, you go back to YouTube. This video is already there. So is that on? Do you understand? Is that clear?
Yes, it's quite clear. I mean, you've done justice to the questions, but I just want to quickly ask, how do you know the particular steps to follow? Like, how you're just following things sequentially, you know what to do at each point. How do you know,
Okay, that's why I said it's still in the documentation in scikit-learn, that's sklen. If you are using scikit-learn for creating your machine learning models, that's supervised learning. What we're doing is under supervised learning, which is regression. In supervised learning, there's regression and classification. Regression is you're predicting numbers. Classification, you're predicting this from this, yes or no, this person has that disease or not, or whatever. So those are the differences. So in the documentation, there are steps that are already laid out on how to follow. First of all, just like what I did, process your data sets to numbers by which the algorithm will understand. If you can see my cursor. So our data set wasn't like this. There's something we call preprocessing in data science. You have to, and that is the hardest, because this data set is just small, so it seems that you just did it easily. Processing your data is the hardest one. Cleaning your data sets, removing outliers and what have you, label encoding, blah, blah, blah. So you have to process your data set to the way the algorithm can take. So you understand. Then there are laid down steps. After calling your model, you split it into X and Y. you split it into your train and test sets. Then you fit the model. After fitting it, you score the model. And after that, you take your predictions. So these procedures are already in the documentation in scikit-learn. Just go to scikit-learn, Google it, you take it to the documentation. It's laid down procedures. That's how I know it. So have I explained it clearly?
Yes, thank you.
Please, is it possible to have the IPYMB file? Can it be shared?
Yeah, I can share it. Just check the announcement channel on Slack. I'll share the file and the data set. And also, you can always come back to this video. It's on YouTube. It's streaming live there. So on our channel.
Okay, thank you.
Sorry, one question.
Okay, I'll just give question for like the next 5 minutes. We'll use over almost 2 hours now. Okay.
Sorry.
So
this under your helper function, this learn total remaining, where did that come from? I really did not see you program anything like that in your helper function.
Where? Which? Where? Which one are you talking?
Underscore, yeah, under the score cell.
Okay, yeah. This one I did time here. This one.
No. Those the output.
Okay. What you are seeing here is this is. Let me show you. Let me scroll up. Can you see it?
Yeah, these stuff. Yes.
This is the output form of cat-boost regression algorithm. Is the default way it's showing what is learning, because the default learning rate is 1,000. You also know this. Okay, let me show you. Explain it to you. We are using cat-boost. Let me show you what I'm talking about. Okay. You see these values here? Can you see it?
Yes.
Can you see it clearly? So there are different ways and values in each regression. There's iterations, there's learning rates. These numbers you are seeing from 1 to like 1,000 is the learning rate. The default learning rate, even if it's showing none, default learning rate is 1,000. I didn't do that. It's just a default setting in cat-boost regressor. So that's what we show. It's just the cat-boost I showed that if I did just the random forest, it will bring out these values. So this is what is in the cat-boost default setting. So it will just show you the learning rate. If you notice, the learning rate reduced from 24 to 4. So that's for cat-boost and gradient. Okay, gradient boost, it doesn't do that, just cat-boost. So this is just like a default, what they programmed in cat-boost. Okay. Who else was raising a hand then? Let me see. Okay, tell me, yeah, you can ask a question.
No, I'm the one that asked the question just now.
So. You're the one. Okay. So, in case there's no question, thank you very much for this session. I hope it was very insightful. I didn't bore you or whatsoever. So,
I have one question.
Okay, what's the question?
Is it always advisable to like use different models? But how would we know which one? Because before you found out that cat-boost was the best, you tried 4. How would we always know like which ones we should use to find the best?
Okay, like I said, there are different regression algorithm. If you are good with statistics and you know your data set well, you would know which is good for which. But if you're not that good with that, you can just do what called, it will take time. So I can just do like I did my test and run now. I just did a test on 4 different regression algorithms. So as I did my test with the base model, I saw that cat-boost was best. So it's advisable that instead of you to stick with one model, you can work with different other algorithms. So if you are working with regression, you select all the different regression algorithms and create your model. So that's just
okay. Thank you. Thank you.
Okay, one more question, then I call it a day. Okoli, did I pronounce that well? Okay, please ask a question. Okoli, you can ask a question. Should I stop sharing my screen?
If Okoli is not asking me, I want to ask you.
Yeah, ask a question.
Yeah, I noticed something about you when you were talking about label encoder. Well, recently I just read something about maybe label encoder and one of them about label encoder and one of the good name. So the person said label encoder, it creates ordinality in our data, like saying maybe for example, if Lexus was assigned to 1 and Toyota was assigned to, in the data, the algorithm might see it as Toyota greater than Lexus or Toyota greater than Honda. So is that not going to affect the reading of the data in the algorithm? But one encoding, fine, it might create more columns, but at least that ordinality will not be in the data. Or my question should be, what is the drawback of ordinality in data because of this label encoding?
Okay, fine. Let me answer that. Like you said, ordinality, yeah, the algorithm might see that this one is higher than that. But at the end of the day, should I say the difference or the effect would be that it will be very minimal. But the how you know when to use label encoding, for example, gender, in your data set, you have male and female. It's best you can use label encoding there to just say the male is 1, female is 0. That's how it normally does it. But one not encoding, it would, like you said, to create different columns. But even with that one hot encoding, they use label encoding because it can save your what we call round, should I say round space, or the storage. The storage is taken in that particular system, even if you are using a GPU or a TPU. But both of them works well. If you see your further research, you see that the effect is not that much. That's the ordinality you're talking about. It's not that serious.
All right, thank you.
You're very welcome. Okoli, you can ask your question and let me just
please, can you scroll down, please?
Okay. Yeah.
Yeah, that's line 31.
Okay.
Scroll down more. Yeah, line 31. That compare.t dot plot. Please, that dot t, what is it serving there, or is it a representation? Is it an inline as an inbuilt function also? Because what I know is PLT, just like from what when you said matplot.pyplot as PLT. I don't know why you changed it to T, or is it something else?
Okay, let me explain. What I did there, this T I did was just to transpose the way my visualization will come out. If I didn't put this T, instead of it being vertical like this, yeah, it will be horizontal. So for example, I'm having many values to present. Horizontal would do it justice. So this T is just like transpose it from a vertical representation to this vertical. That's just it.
So is this like serving the same function as like bar H?
Yes, you can see that. You can.
Okay, so invariably you can remove .t and say bar H, and it might also give you this. Okay.
It might, but if you want to try, it might not give you. Okay, let's just try. It might not, but let's just try.
Dot plot.
Oh yeah.
Compare dot plot.
Bahish, you see it's showing like still the same horizontal I was talking about.
By H would actually make it still horizontal. It will not change it to vertical.
It won't change to vertical. Okay, let's call it normal bar.
Let's see. Yeah.
Normal bar, it's made it close together. But what I was explaining is that, for example, we have a lot of data sets. To give your visualization beauty, I just transpose it so that there will be space. And instead of showing different colors and if you notice, my legend changed. Arrow 2 came down and the color changed to the different models. So what I did with T is just to show that each of them, this is the arrow 2 score of each particular model. So that is just a better visualization. So you get them wrong. What I'm talking about. So, I have a question. Wow, this was a very, very, very wonderful session. I hope you enjoyed.
Yeah, we did.
Yeah, thank you for taking your time to.
Yes, thank you so much.
Thank you.
Thank you for the section.
Thank you very much for
them.
More questions will arise at the general channel.
No problem. If you have a question, you can always ask.
Okay.
You can always ask. Okay, yeah, this session lasted for 2 hours. Wow, that's interesting. This is just a special Ask Me session, and I guess just the data scientists and data engineers have benefited from.
Please, can we have more of this kind of sessions?
Yeah, moving forward, we can.
Please, we should.
No. Who gave you that thing?
We should. Okay, so thank you very much. Yeah, I know the question is here to probably please, you can unmute yourself. That person there, please unmute. Sorry, mute. Okay. Okay, thank you very much for this session. It was wonderful having you here with me. Okay, we'll call it today. See you on Slack. If you have a question, ask. And please, like I said, for the premium project, you have to be active in your group. If you are not an active member, it may be detrimental to you having your certificate at the end because there are grades and scores attached to it. So that's what I'm about to say for that. So I'm just saying it now so that in case later on you say the info wasn't passed to you. So our deliverables are premium project, important capstone project, your tag along code, your quiz, attendance to webinars, important webinars. This is not an important webinar. So thank you very much for your time.
Okay, so sorry, a quick one just before you close.
Okay.
This is pertaining to the Premier project. I wanted to ask if what you just did now is kind of what is expected of us for the Premier project.
Okay, thank you for that question. Exactly. You have to, for a Premier project, if you notice the data set you're working with, this is just a small data set. You might be working with just data set that you have to do your cleaning, converting, encoding, and all that. This is just like an end-to-end you're supposed to do. But this, I didn't do any form of deployment. That's why in your group, you have the data engineers to get source data clean or arrange the data. You have the data scientists to clean and whatever to also create the model. You have the data storytellers who would visualize the data. Then you also have DevOps there in the group too. So it's just like an end-to-end. You also deploy it, your model. So I'm just giving you the better you do your particular problem statements, should I say the higher grade you have. So that's just it. This is just a simple end-to-end, but it's not like a complete end-to-end. A complete one, you test it with an unknown data set that this particular model hasn't seen. So we don't know if this model will work good with a foreign data set. So that's just, I'm just giving a brush on how your premium project should work with. So you have a data set, you can come up with a problem statement on what to solve. Do you understand?
Right.
Okay, thank you very much for this session. We'll call it a day. So that question you have
please
again.
Send us the data sets now.
Yeah, I'll post it later on the Slack announcement.
Okay.
All right. Thank you very much. Have a lovely day. Bye for now. See you next time on Friday.
Bye. Bye.
Bye. Thank you, Christian.